Hi class, in this video we're going to learn how to name alkanes, and then we're going to talk about some properties of the alkanes. Many years ago there weren't that many known organic compounds, so when an organic compound was discovered, the person that discovered it would name it any way they wanted to. In fact, they might name a compound after a friend or a daughter or son, or just however they wanted to name it. Anyway, as more compounds became known, it was important to find a systematic method of naming these new organic compounds. The system that we use now was devised by the International Union of Pure and Applied Chemistry. And so the naming system we use is the IUPAC naming system. So in this IUPAC naming system, there are three parts to a name for any organic compound. First, we have a prefix, and that specifies the location of substituents and functional groups. We have the parent name, and that tells us how many carbons are in that longest continuous chain, and a suffix that tells us what family the molecule belongs to. So for example, in this chapter for alkanes, the suffix is ane. In the next chapter, we're going to be talking about alkenes, so the suffix would be ene. So let's define what a substituent is. It's an atom or group of atoms that are attached to a carbon on the parent compound. Here is a general formula for alkanes, where N is equal to the number of carbon atoms. So for example, we have a 6-carbon alkane, and N would be equal to 6. So we would have C6, and then as far as the number of hydrogens, we have 2 times N, so 2 times 6 is 12, plus 2 is 14. So this is a very easy way to write a molecular formula for an alkane. So what we're going to do here is, first we're going to name the straight chain alkanes, and that's pretty easy. All we do is count the number of carbon atoms and add the suffix ane. What you are responsible for is learning the name and structures of the first 10 alkanes. Okay, so we'll go through these. A 1-carbon alkane is called methane, 2 carbons ethane, 3 carbons propane, 4-carbon butane, 5-carbon pentane, 6-carbon hexane, 7-carbon heptane, 8-carbon is octane, 9 carbons nonane, and 10 carbons decane. This is for the straight chain alkanes. And just for your information, here are another 10 names. So if we have an 11-carbon straight chain alkane, its name would be undecane, and so on. You don't have to know 11 through 20, but you will need to know 1 through 10. Again, these are the names of the first 10 straight chain alkanes. Now, naming branched alkanes, well, you have to know a few rules. So before we go into naming branch chain alkanes, let's define what an alkyl group is. An alkyl group is a substituent, right? That's what's on that branch point, such as the methyl group and the ethyl group, and these branch off the main chain. What we do is we replace the ane with YL. So for example, we have a 1-carbon alkyl group, so rather than calling it a methane group, we would call it a methyl group. Here we have an ethyl group. It gets a little more complicated for the larger alkyl groups. So for example, here we have a propyl group. Okay, remember 3 carbons, that corresponds to propane. This would be a propyl group. This here just shows the point of attachment. So this would be a propyl group, and there are 2 different ways that this group can be connected to a carbon on the main chain of the compound, either by one of these end carbons, okay, and this would be a straight chain propyl group, and we would sometimes give it this prefix here, N. We would call it N-propyl, and the N just means normal or straight chain. Now, another way that this 3-carbon alkyl group can be attached would be through this middle carbon here. And in this case, what we have here is a branched chain alkyl group. So when this 3-carbon alkyl group is connected by an inside carbon, or the center carbon, then we call this an isopropyl group. Okay. Now, when we get to butane, it gets even a little more complicated. And so there are actually 4 different ways that we can attach the 4-carbon alkyl group. By one of the end carbons here, in this case we would have what we call an N-butyl. By one of these, the second carbon, either this one or this one, that would be called a secondary butyl. Sec is just abbreviation for secondary. And here we have an isobutyl, and here we have a T-butyl, or a tertiary butyl group. There are others, for example, when we get into pentyl groups and all of that, but we won't cover that here. You're only going to be responsible for the methyl, the ethyl, the propyl, isopropyl, and the N-butyl, sec-butyl, isobutyl, and tertiary butyl alkyl groups. So before we go on, we will start naming these very soon. We also have to look at the types of carbon atoms we have. Okay, we have primary carbon atoms, and this is a carbon atom with one other carbon attached to it. Before I go on, we see this R substituent, and that just corresponds to any alkyl group. All right, so for example, this could be this group here or any other alkyl groups. So you can think of R as representing the rest of the molecule that we just don't bother to specify. So R could represent a methyl, a propyl, or any other possibility. Okay, a secondary carbon atom is a carbon atom that is bonded to 2 other carbons. So in this case here, this carbon here would be a secondary carbon. We can also indicate primary carbons with a 1 and the degree symbol, a secondary with a 2 and the degree symbol. We also have tertiary carbons, and as you probably have guessed already, this is a carbon atom that is bonded to 3 other carbon atoms. And again, this can be represented like so. And then there are quaternary carbons, and of course that'd be a carbon bonded to 4 other carbons or 4 other alkyl groups. How do we name these branched alkanes? Step 1, we find the longest continuous chain, and that gives us the parent name. What we do is number the carbon atoms in the main chain. So let's go ahead and do one here. The longest continuous chain here has 4 carbons. So we would go ahead and name this as a butane. And then we have to give the location of the alkyl group. Well, we have a methyl group here, and it is on carbon. Well, if I count this way, starting here, that'd be 1, 2 on the 3rd carbon. But then if I start counting this way, 1, 2, 3, 4, it's on carbon number 2. We want our branching substituents, or at least the first one that we come across, to be on the lowest number carbon. So in this case, what we have is a 2-methyl butane. Okay, if we called this 3-methyl butane, it would be wrong. So we have 2-methyl butane. And we write the name as a single word. We use hyphens to separate the numbers from the prefixes. And if we have 2 or more substituents, we'll use commas to separate the numbers. If more than one substituent is present, then we need to cite them in alphabetical order. So even if, let's say, we have both an ethyl and a methyl group, okay, and let's say the ethyl is on carbon 6 and the methyl is on carbon 2. Ethyl has alphabetical priority, so this would come first in the name. If 2 or more identical substituents, like maybe 2 or more ethyl groups or 2 or more methyl groups are present, we have to use the prefixes di, tri, tetra, and so on. Of course, di is for 2, tri is for 3, tetra is for 4. So I think the best way to do this is just start naming some of these compounds. What are the IUPAC names of the following alkanes? So the first thing we need to do is find our longest continuous chain. So if I count across like this, 1, 2, 3, 4, 5, 6, 7, I have 7 carbons. Or let's try this, 1, 2, 3, 4, 5, 6, 7, 8. Oh, my longest chain is 8 carbons. So what I have here is an octane, so I name the parent first. And then I start numbering my carbons to find out where the substituents are. I'll start here, 1, 2, 3, 4, 5, 6, 7, 8. When I number this way, I have a methyl group on carbon 3 and another one on carbon 7. So I have a 3,7 methyl. Let's try numbering the chain the other way. We want the lowest possible numbers for the first substituent. So let's do this way. I'll just change colors here. Oops, it didn't change my color. So here we'll go 1, 2, 3, 4, 5, 6, 7, 8. Again, I want the lowest possible number on that first substituent. So in this case here, I would have a 2-methyl. I'd have a 2-methyl, and let's see. So I have a 2, and the other one is on 6. 2 is lower than 3, so I would call this, I would use the 2,6 to indicate the carbon number, the numbers that the methyl group is attached to. And because I have 2 methyl groups, I have to use the prefix di. So let's put this together. So here's what I have. I have a 2, 6 hyphen dimethyl octane. That is the name of this compound. If I would have named it 3,7-dimethyl octane, that would have been wrong. Let's go to this one. So again, I'm looking for the longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7. Okay. And let's try again. 1, 2, 3, 4, 5, 6, 7. It looks like the longest chain is 7, so that is a heptane. And if I number the carbons this way, I have 1, 2, 3, 4, 5, 6, 7. And I have, on carbon number 5, I have 2 substituents. Here we have an ethyl and another ethyl. So let's number the other way, because again, we want those substituents, that at least that first one, on the lowest possible number. So 1, 2, 3, 4, 5, 6, 7. So when I number this way, the ethyl substituents are on carbon number 3. So that's what we're going to go with. So what I have here is 3, 3. Yes, I have to include the second 3, okay, because both ethyl substituents are on carbon number 3. So I have 3, 3, diethyl heptane. Let's go ahead and name a few more. It's very important that you are able to name these alkanes, because this is going to be the basis for the rest of the nomenclature for other compounds. So let's go on. We'll name some more compounds, and then I suggest you practice it, because they're going to look very different on an exam. So let's take a look at this one here, and let's see how we got this name. So I'm going to number my carbons 1, 2, 3, 4, 5, 6. So I have a hexane, and on carbon number 3 is a methyl group. So this would be 3-methylhexane. Let's take a look at this one. The longest continuous chain here would be 1, 2, 3, 4, 5. Okay. Or I could go 1, 2, 3, 4, 5. And so it's 5 carbons. So therefore we have a pentane. So let's go ahead and number this 1, 2, 3, 4, and 5. So on carbon number 3, I have a methyl group. So this would be 3-methylpentane. Let's take a look at this one. My longest continuous chain is 1, 2, 3, 4, 5, 6, 7. And let me just try a couple of other possibilities. 1, 2, 3, 4, 5, 6, 7. I'm just going to go with this here. Okay. So we have 7 carbons. We have a heptane, and 1, 2, 3, 4, 5, 6, 7. So that means on carbon 4, what I have is this propyl group. And in this case, we have a straight chain. Remember I told you that we use N-propyl for a straight chain. Sometimes they eliminate that N, and that's the case here. So anyway, on carbon number 4, I have the propyl group. So we have 4-propyl heptane. Or I could go ahead then and name this as 4-N-propyl heptane. That's all one word, by the way. Let's go to this other one here, and let's find the longest continuous chain. It looks like it's 5. So we have a pentane. And on carbon number 3, what we have is we have a methyl group and an ethyl group. Okay, so I have 3-methyl, 3-ethyl. Ethyl has alphabetical priority. It comes first. So we have 3-ethyl, 3-methylpentane. Remember, hyphens separate numbers from the different prefixes. Now, so I couldn't name this 3-ethyl methylpentane because I have to indicate which carbon the methyl group is on. Even if it is the same carbon as the ethyl, I have to have the 3 in here. So this is the correct name for this substance. We already know if we have multiple identical substituents that we use the prefixes di, tri, tetra, and so on. Let's go ahead and try this one. Our longest continuous chain is octane. So we have 8 carbons. So we name it as an octane. Let's number the carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I number them this way, on carbon number 3, I have 2 methyl groups, and on carbon number 6, I have an ethyl and a methyl group. Well, in this case here, I could also number them this way, where I have 1, 2, 3, 4, 5, 6, 7, 8. And this way, this would give me an ethyl group and a methyl group on carbon 3, and 2 methyl groups on carbon number 6. So which way do I name this? Well, what I do is I choose the ethyl group to be on carbon number 3, and then the 3 methyl groups to be on carbon number 3 and carbon number 6. So why don't I just call it 6 ethyl 3 6 trimethyl octane? That's because in a case like this, the ethyl group has alphabetical priority. So I want that on the lowest number. So I go ahead and number this way. So I have ethyl comes first. It has alphabetical priority. It's on carbon 3, so that's 3 ethyl. I also have a methyl group on carbon 3 and 2 methyl groups on carbon 6. I use the prefix tri. 3 ethyl 366 trimethyl octane. And then here we have, again, the longest continuous chain here is 8. So we have octane. And on carbon number 4, I have a propyl group. This is a straight chain propyl group because it's attached by the end carbon. So this would be 4N propyl octane. Remember, the N is for straight chain. Again, for the straight chain attachments, when it comes to propyl, sometimes this N is eliminated. Even though we have a systematic way of naming, okay, sometimes there's even more than one systematic way of naming a particular family of compounds. And then here we have the same thing, 8 carbons in the longest continuous chain. This is octane. And on carbon number 4, we have this 3-carbon alkyl group, but it is attached by this middle carbon here. So this would be the isopropyl. So we have 4 isopropyl octane. Now, what we're going to do is draw some structures here. Actually, that's probably easier than naming them. So we're going to draw structures that correspond to 3-methylhexane. So I have a 6-carbon chain. That's my parent chain. So I'm going to go ahead and write this. So I'm just going to do condensed structures here. So I'm going to have this. It's on carbon number 3 that I have my methyl group. Okay, so what we have is 1, 2, 3, 4, 5, 6. We have the hexane and a methyl group on carbon number 3. Here they want me to draw 2, 2, 4 trimethyl pentane. I'm going to have on carbon 2, we're going to have 2 methyl groups. And on carbon 4, I'm going to have 1 methyl group and then this. So I have my pentane and I have methyl groups on carbons 2 and 4. And then they want us to draw 3,5-dimethyl octane. CH3 carbon number 3 has a methyl group. So this would leave me with a hydrogen here. And then on carbon number 5, I have a methyl group, and then carbon 6, carbon 7, carbon 8. Okay, now they want us to identify the carbons as primary, secondary, tertiary, or quaternary. So let's take a look here. Here we have a carbon. It's bonded to one other carbon. This is primary. This carbon here is bonded to two other carbons. It is secondary. This carbon here is bonded to 1, 2, 3. So this carbon here is tertiary. And then, of course, this is secondary, secondary, and primary. Okay, so let's take a look at this compound here. This carbon here is primary. It's bonded to one other carbon. This carbon, 1, 2, 3, 4, this would be quaternary. This one here is secondary, and this one here is tertiary, and then primary. And then as we go along here, we have a primary. Here we have a secondary. This carbon's bonded to two other carbons. Here, this carbon is bonded to 1, 2, 3 carbons. This is tertiary. This one here is secondary. This one here is tertiary. And then here we have secondary, secondary, and primary. So make sure you practice those. So let's take a look at some of the properties of alkanes. The first four alkanes, methane, ethane, propane, and butane, are gases. Methane, of course, is natural gas, and we're all familiar with propane, which we can get in tanks and use for our grills. Alkanes with 5 to 15 carbon atoms are liquids. Alkanes with 16 or more carbon atoms are usually low melting, waxy solids, so they melt at low temperatures. Alkanes are nonpolar, and because they're nonpolar, they have very weak London dispersion forces holding the molecules together. For straight chain alkanes, melting points and boiling points increase with size. So here's a chart that shows us the straight chain alkanes. Here we have temperature on this axis, number of carbons, and we can see that these melting points and boiling points increase with an increase in the number of carbons. Actually, so the boiling point will actually increase 20 to 30 degrees for every methylene group that is added. So, and we can see that right here. It turns out they're branched, they have smaller surface areas, and they can't pack as well together as the straight chain can. So they usually have lower melting points. And remember, if they can't pack as close together, then the London dispersion forces are not as strong as when you have a straight chain alkane that can pack together closely with other alkane molecules. Alkanes are insoluble in water. Well, they're nonpolar, but they are soluble in nonpolar organic solvents. They are less dense than water, and our lower molecular weight alkanes are very volatile, and they're flammable. Alkanes are not that reactive. In fact, we're only going to talk about two reactions that alkanes undergo. The first reaction that we're going to talk about is combustion. The reaction of an alkane with oxygen will occur during combustion. This could be in an engine or in a furnace. And in complete combustion, the products are carbon dioxide and water. Incomplete combustion is going to produce carbon monoxide and also some carbon soot. We have to be very careful if we have a faulty engine or a furnace. We want to make sure our furnaces are in proper working order so that we don't produce that carbon monoxide. What we want is complete combustion. So we take an alkane, react it with oxygen, and our product in complete combustion is carbon dioxide and water. Okay, so again, complete combustion only produces carbon dioxide and water. Incomplete combustion, so when your engine's not working properly or your furnace is not maintained, that's going to produce very toxic carbon monoxide. So here we're asked to write the equation, a balanced equation for the complete combustion of ethane. I'm just going to go ahead and write the molecular formula for ethane. And we know that's a gas. And of course that would be reacted with molecular oxygen. In complete combustion, we only get 2 products, carbon dioxide and water. And you're going to ask, sometimes you'll see the water as a liquid and sometimes as a gas. And that's just going to be dependent on the temperature of the combustion reaction. So at higher temperatures, you'll get the gaseous water. At lower temperatures, liquid water. So now we need to balance this equation. I have 2 carbons on this side. I'm going to go ahead and put a 2 here in front of the carbon. I always leave the oxygens until last in these types of reactions. Here I have 6 hydrogens, so I'll put a 3 in front of this here. So now for the oxygens, we have 2 oxygens here. Here we have 4 plus 3, that's 7 oxygens. Now, if you remember back from Chem 251, 7 oxygens would be equivalent to 7/2 of this molecular oxygen. 7 oxygen atoms, 7/2 of this would be 7 oxygen atoms. So what I do is I go ahead and put that 7/2 in front of the oxygen. Okay, but I can't leave the fraction here. So to clear the fraction, I multiply everything by 2. So I have 2 of these. And then, of course, if I multiply this by 2, I end up with 7 oxygens. And then we'll multiply this and this by 2. And we end up with 4 and 6. So let's go ahead and check this. I have 4 carbons here. 12 hydrogens, 12 hydrogens. 7 times 2, we have 14 oxygens. Here I have 8 oxygens plus 6, 14 oxygens. This is a balanced combustion reaction. The second type of reaction that an alkane undergoes is called halogenation. Okay, so basically we're going to see 1 or more hydrogens of the alkane replaced with a halogen. Usually we'll use bromine or chlorine. So in this case here we have methane plus molecular chlorine to produce carbon tetrachloride and 4 hydrogen chlorides. Okay, so we see that this is a balanced reaction here. But a lot of times in organic chemistry, what we'll have is a mixture of products in the reaction vessel, just like this. You don't have to know all of these products here, okay? But we can see that either 1 hydrogen can be replaced with the chlorine, or you can have 2 hydrogens replaced with the chlorine, 3, or even 4. It just depends how long I let the reaction go for, okay? So I might only want this product here. So I would adjust the reaction conditions to get that product. This arrow should go here, okay? So I just want you to be able to recognize that the 2 major reactions that alkanes undergo are combustion and halogenation. Recognize a halogenation reaction or a combustion reaction. Okay, that's the end of this video. I'm going to post one more video on the cycloalkanes, and that will end chapter 19. So everyone have a great day, and I hope to see some of you around campus.